Okay, so before I get into explaining how we know the universe is expanding, I wanted to start with a more basic and familiar concept that we've all experienced in our everyday life. And so I want you to imagine you are stationary, sitting on a park bench or standing up near a road, okay? And you hear a car from a distance blaring very loud music, and it's approaching you. It's on the road, but it's approaching you. And you notice that it's playing a song, right? And as it's moving towards you, you hear that the song starts to sound distorted. Like it seems that the pitch is changing, something about it seems weird, right? And as it passes you and then it moves away, and then the sound is still, it's changing. It seems like it's distorting, right? So this is called the Doppler effect, which basically states that when a source of sound approaches you as an observer, the observed frequency of that sound increases. And then when a source of sound moves away from you as an observer, the observed frequency of those sound waves decrease. So say this is you, the observer, and then this police car siren is moving towards you. It's the source of sound moving towards you. So you as an observer will start to hear that this police car siren's frequency is increasing. But then when it passes by and then starts moving away from you, the observed frequency starts to decrease. And the thing is, the Doppler effect applies to light as well. So instead of a source of sound, I want you to imagine that this police car siren is a source of light. So the same principle holds, right? A source of light approaching you as an observer will appear to have a higher frequency. And when that light passes by and then starts to recede from you, the observed frequency of that light starts to decrease. Higher frequency in light appears blue and lower frequency in light appears red. Now, this is in theory. The light source would in reality have to be moving a lot, like at an extremely high speed for you to actually notice like a change in the color. It's much easier to notice with sound, but it's not as obvious with light. This is called blue shift when it approaches you. When it recedes from you is called redshift. And those two concepts, particularly redshift, are key to helping us understand that the universe is expanding. You've probably heard that it was Edwin Hubble that discovered that the universe was expanding, but actually, a decade before he published anything related to the expansion of the universe, a number of physicists and mathematicians had theorized that the universe was expanding because they derived the math from Einstein's equations. But since Edwin Hubble's story is the most popular, we will start with him. So it was around the 1920s when he was looking through his telescope, and then he noticed these red fuzzy things in the sky. He'd realized later on that these are actually galaxies, and that they were just extremely redshifted. To prove that, he found the distance between Earth and those galaxies using the Cepheid variable and the standard candle. And with the help of De Sitter and Humason, Hubble's law was formulated. And this law basically says that the further away a galaxy is, the more redshifted it is. And this was really important for us to understand that the universe is expanding, because seemingly all galaxies in the observable universe are redshifting. Not only does that tell us that they are getting further away from us, but the further they do get away from us, the faster they recede. So you might ask, doesn't this really just tell us that everything is moving away from Earth? So we observe that things are moving away from us. Doesn't that just tell us that the universe is expanding, but with us as a center? And the thing is, as we know from Copernicus, we are not the center of the universe. Scientists have observed redshift from all directions, and also things like cosmic microwave background radiation also tell us that the universe is uniform across its entirety, not just centered around Earth itself. And so with that, we're saying that the universe is expanding in all directions. So if it's expanding from our point of view, you can assume that if you were to go to another galaxy, you would see the same thing. And it's kind of hard to visualize that. So think of it like this. Say you have a balloon and it's deflated, and you have a Sharpie, and you draw 3 dots in the form of a triangle on the balloon. And then you inflate the balloon, okay? You blow air into it and you expand it, and then you start to notice that the 3 dots start to diverge from each other, okay? So they're starting to have distance between the 2 dots. Now, you can imagine that the balloon is the fabric of space and that the dots are our galaxies. So what's actually happening is that it's not that the distance is just increasing between these two galaxies, as in like there's just more space between them. It's that space itself is stretching. Think about it. The balloon, after it's inflated, it's stretched out, right? Now, if it was merely just the space between two galaxies increasing, that would be more like you erase one of the dots and then you redraw it to be further from the other dots. That's not what's happening. It's that the fabric itself of that balloon, the fabric of space, is increasing itself, okay? So that's a common misconception. Now, you might ask, are we stretching in that case? If all of space is stretching, does that mean like our galaxy is stretching? And no, because apparently gravity and other forces are stronger than cosmic expansion. And by other forces, we mean dark matter. So it is theorized that there are two things that are causing this cosmic expansion, but also causing us to stay intact. Okay, the first thing that's causing cosmic expansion is theorized to be dark energy. But the other thing that's helping our galaxy, the reason why our Milky Way galaxy is not flying apart is because we're being held together by something called dark matter. And dark matter and dark energy make up about 95% of everything. So we are swimming in dark energy and dark matter right now. And it's hilarious because we actually have no idea what it truly is. We just theorize it to be there. So in sum, redshift tells us that all the galaxies that we are observing are moving away from us, but it also tells us that this is happening at every point in space because we're not the center of the universe. The universe is expanding in all directions. And this is theorized to be due to dark energy, but the thing that's keeping us together is dark matter.